Hi, good evening.
Hello. Cam, Heidi, and Phoebe, did Zoom send you the invitation link, or did you just go to the Canvas shell page and follow the link?
I just went to the announcement that was from yesterday.
Yeah.
Okay.
I opened up the email from yesterday, from the other day, with the Zoom link.
Okay. Yes, it didn't change. It's like, it's 4 o'clock and I wondered if it was being glitchy.
I originally went to the lab meeting from Monday, so I wonder if people are doing that, going to the other Zoom link.
I think my account number, or whatever you want to call it, I think doesn't actually change. I think that whatever my faculty designation code is through Zoom, I think is the same number for whatever I teach. Or at least that was kind of my assumption. I'm not really actually sure about that. I'm trying to figure out if there's a way to send a new set of invitations. Because pretty much everybody who's on my roll showed up for Tuesday. And I created this meeting a couple of days ago. So it should have been, I thought, sent to all the student accounts. Oh, here's a problem though. Part of SIS just crashed.
I think that happened last semester because there's so many people trying to get on.
Yeah. It's like I clicked on the tab that's supposed to be like show like the SIS, my faculty link to SIS, and it went unavailable. So yeah, that could be a piece of the problem. So I guess I'll dawdle for a few more minutes and see if maybe the system kind of kicks itself back into gear.
Hi, everyone.
Hello, did you have trouble logging on?
Me, no. I just went to the email you sent, and I just put the Zoom the meeting code and the password, and then boom.
Okay, just because I know I flipped over to the tab with the SIS and it didn't look like it was available. So I'm thinking that SIS is being problematic about how it hooks all the accounts together.
Yes, I think so. And I think maybe the other student normally they other teachers always send like an invitation every day that they're gonna have the meeting. Maybe they're waiting for an email or something else, maybe. But if they don't go to your email and look for the information you give for the meetings, they
Yeah,
probably not.
I put the permanent invitation on one of the page functions. So you can always scroll down the Canvas, the shell and go down to the page and it says like permanent Zoom link.
Yes, 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 I do.
Because yeah, if I open it up and if I look at it from my end and I look at pages, yeah, it's labeled Zoom invitation link for whole semester.
Yes.
Because yeah, it's like I'm pretty sure that that my faculty ID code or whatever it's called for Zoom actually doesn't matter whether it's for a lecture or for a lab. I think my whatever the multi-digit code is, I think actually doesn't change.
Yes. Yeah.
Because I'm like the designated host for the class.
Yeah, it's still the same. Yeah, it did not change. I put the same information you put in there, and then I'm here.
Yeah. Like I said, and I think it actually doesn't even change the code number. I'm not even sure changes from lecture to lab.
Nope, I'm not sure. The same one.
Are we having an issue with getting the class in here?
Yeah. It's like I have.
I can see that there's 7 people. I'm like,
yeah,
there's
it's
no way
like,
there's so many last time.
12, 13 people out of my 15
Yeah.
showed up for Tuesday. Of course, like I said, when I clicked on the SIS
Right.
claims unavailable.
Huh. Oh,
That's
that
weird.
happened to me the other day. She said you have to refresh your browser's like cookies and your data, like clear your browsing data and then close the Safari app, or not Safari, I'm sorry, Google Chrome. And then I guess it fixes it, and it did for me. I don't know what the
Okay.
issue is there.
Yeah,
Yeah.
and I'm sure it has to do with how many students are using the system.
Yeah.
Yes, and I also think like it'll be like easier for them if they download the whole schedule you sent. If they download it on the calendar, they will send them like a notification before class with the link for the class for them to get in. It'll be way more easier.
Yeah. I mean, I just went to your old email though, and that worked fine. The one you sent.
And like I
just
said,
the-
there's
Exactly.
one of the pages says Zoom link for whole semester.
Yes.
Yeah, I mean, it works. I don't know.
Oh, the joys of having to Zoom everything. Well, at least we get to see each other for lab every couple of class periods, so that helps. So my latest discussion with the guy who's above me in the food chain, it is that for fall semester, for instance, if you are potentially planning on taking 112 in the fall, there is now a hypothesis going around that they're still not sure what they're doing about lectures, but they think that chemistry labs are going to go back to a full regular schedule for the fall semester. So hopefully we're moving in the right direction.
Right.
I know a couple, I'm not sure if it was any of the people who are currently long gone. A couple people had asked me about the videos from this, and apparently I cannot post links directly from my Zoom recording to any students. What I have done in the past, and this is really problematic, is sometimes I've managed to get them to upload to YouTube, but the problem being that, unlike a video of somebody just, hey, watch me on the diving board or something like that. These videos are 90 to 120 minutes long. And some of the ones I have loaded in the past took 12, 18, 24 hours for YouTube to even process. This is not designed to be an asynchronous class. This is designed to be a synchronous class. So trying to repost them across to another platform is difficult, unfortunately. At least that's most of the people who've finally gotten logged in now. Oh yeah, using your phone's fine. So let me talk about lab for a couple of minutes before I kind of digress back into lecture stuff. So group A people who are listed, when you log into the shell for lab, there's an announcement that says like groups A and B, okay? Because right now, even though they finally like ditched the mask mandate and all of that, we're still limited to 12 students max per lab session. And since I have 15 students, that means I had to divide them basically in half. So group A, at least as of my last look at my roll sheet, was Isuzu, Fonville, Javier, Miles, Price, Skurzak, Thomas, and Ubadich. So those are the group A people who should have been there yesterday. Then over the course of the upcoming weekend and on into next Wednesday, since there's no Monday lab, obviously, the dry lab is in your lab book, okay? But there are some instructions to kind of guide you along, and they're not as a module. They're a page function. So when you click on the page function on the left-hand side of the page, and they're unfortunately alphabetical and not chronological. Look for Dry Lab 1, and when you pop it open, there should be a digital version if you haven't gotten your lab book, but try to get those as soon as possible. But there's a digital copy of Dry Lab 1, and I actually finally figured out how to load the extra exercises page, which is the thing that all my A group people did in lab yesterday. B group people, the other half of the class, I will see in lab next Wednesday. So over the course of this, next 5 or 6 days here, you should be also working on dry lab because it was your original set of assignments. It's mostly math, okay? Let me grab my lab book here. But like I said, I did a digital download or a digital posting, okay? This is what it looks like in your lab book. It should say Dry Lab 1. It has gray edged pages on it. And if you're looking at the dark numbers that are printed here, this is page 43. So you start reading that. After you go through 2 pages worth of information, you hit this. Okay, this is the actual lab report then. And it gives you instructions about skipping the first couple lines here. These are all kind of true, false, short answer stuff. So read the previous 2 pages, answer the questions. Okay. There's more kind of true, false, short answer stuff until you get to the very bottom of the page here, which is actually where the math starts. Okay. And weirdly, these are A and B and C and D. Don't try to read all the way across the line. This is a really problematic thing that we noticed is people think that somehow the problem goes all the way from the left-hand side to the right-hand side of the page. That's actually not true. It's like this bit, then skip, okay, then this bit. They're not actually connected to each other. The following 2 pages are all conversions, okay? They're word problems, but they're just conversions. So all of these, and there's tips on kind of what you should do and how many answers you're actually supposed to report, because some of them have 2 answers. And then the last page of math is here, okay, including all the way down to this really kind of messy, figure out how the volume of this long pole thing is calculated. Okay, all that's just math. Okay, this page, and I actually finally figured out how to upload that after lab yesterday. This is all being done in the lab. Okay, so if you get everything done but that final page, which is actually in little numbers, page 59, if you get everything done prior to that page, you actually have to wait till you come to lab to do the extra exercises page, because it involves using the balance and using a burette, which is something you may or may not be familiar with. I had posted a little video on the page for Dry Lab 1 that kind of shows you what a burette is and kind of shows you how it works, because people keep trying to read them upside down. And I tried to give you some visuals to make it a little bit more understandable for the 0 is at the top and the 50 is at the bottom. Don't subtract your numbers from 50, because that's not the way it's supposed to work. So Dry Lab 1 is not me Zooming. It's not me doing any sort of presentation. You basically have to log into the Canvas shell for lab, read the instructions, and do the lab stuff. Okay, do the lab book stuff. If you haven't got your lab book yet, try to do so as soon as possible. But that one, there is a PDF scan that's all the first 4 pages of the lab. And then there's a separate file that's the extra exercises page, which you should print out. If you have not done lab yet, you should print out to bring with you when you come to lab next Wednesday, if you are the alternate group. Experiment 1 is also from your lab book. Okay, so you need to bring your lab book with you, because you're going to be doing a whole bunch of different things in the lab and recording your data. Okay. Eventually you can make a decision as to whether you want to turn them in digitally, basically scan them. If you have a flatbed scanner, that's an easy way to do it. But most phones will allow you to download an app that you take the picture and you tell it convert to PDF, and that will then allow you to upload it to Canvas. Or you can just literally bring me the sheets of paper the next time you see me. Okay, either way is an option. Usually I like physical papers to make comments on and that sort of thing. So if you would like to just go ahead and hang on to them until you see me each 2 lab period cycle, that's perfectly fine. Hopefully that helps a little bit with the some of the confusion that seemed to occur yesterday for lab. It's on you. It's weird because of course we did the Zoom on Monday, which was just info. And then you start getting into this sort of off again, on again cycle for lab, where sometimes you see me and sometimes it's just digital. We're trying to cope with that as best we can. So questions about lab, either if you had it yesterday and you're still stumped, or if you have it next Wednesday and you're still not sure what to do. Hopefully that helped a bit.
I actually have a question not related to those. I have another teacher, so is it going to line up for the most part as far as what you're lecturing and then I do with him in lab, or not guaranteed?
Everybody follows the same lab schedule. If you actually look at the lab schedule, the page A and page B
Right.
that are loaded, everybody in the department uses the same schedule.
Okay.
I think, do you have Mr. Siniak?
I believe so. I'd have to go look in my
Okay, so he has, I think his lab, and I'm not sure which, is either Monday night or Tuesday night? And
Yeah,
I'm not sure which
Tuesday
one.
night.
It's
The one
it's
that I
tonight. It's
have.
Tuesday night and Thursdays.
Okay, so
Looking
he's
at the
off
syllabus.
by 1 day from my schedule. So he follows the same schedule. So whatever I talk about, he's doing the exact same labs.
Okay.
The explanation might vary a little bit, but the lab is the lab. Everybody in the department does the same labs for Chem 111 and the same labs for Chem 112. So
Awesome.
yeah, same lab book, same labs.
Right.
Like I said, his explanations might be a little bit different. Occasionally we pick different post lab questions. Occasionally we'll say, oh, skip this one little section that is variable from professor to professor.
Right.
But for the most part, it should
When it comes to the
really-
curriculum and like the tests and stuff. It all.
No, tests are a totally different deal. Okay.
Okay.
There are no
Within the lab.
tests in lab. Some professors give quizzes. I know that Dr. McHugh does, I think, 4 quizzes during the course of the semester. I don't do lab quizzes. I'm not sure about Mr. Siniak. I don't know if he does quizzes or not, but there are no lab tests and there are no lab finals
Okay.
for chemistry.
So all my
That's an
test
A
and
B
finals will
thing.
be with you in the lecture side of the.
Yes.
Okay. That was really my main question. I just wanted to make sure, I wasn't taking like 2 separate tests or something, like one for lab.
And we're using the same textbook for lecture. Also, we're all using the OpenStax textbook, and we don't all proceed at exactly the same speed.
Yeah.
But we all have 9 chapters we have to get through in 10 weeks.
Mm-hmm. Yeah, I mean, it let me add him, so it probably is, not going to pose an issue, or else TCC probably wouldn't even have allowed me to, have him in lab and you in lecture. So I'll probably be all right.
That's actually not unusual. That's not like I know that somebody in my the lab that I had yesterday, I have at least one student who has him for lecture and me for lab.
Okay, he's just opposite of me.
Yeah. So you just have to register for a lecture and a lab that have the same number.
All right, awesome. I'm
111
then.
or 112 or 121. But yeah, no, sometimes, I mean, I think it's beneficial. I mean, I know this from the student end of it. I usually tried to take the same professor for lecture and lab. But it doesn't always work because sometimes
it's just for ease though, not necessary. So that was all I was worried about.
Okay.
Thank you.
All right. So any other lab questions before we dive back into textbook stuff? Somebody had asked me about the file that has more pictures, and I reloaded that. Okay, I'm losing track of days. Tuesday night after I got off of here, I reloaded the file that has more pictures. So that should, we can re-download that if you want to.
All right. So you said the second group is joining when? The second lab group?
It will start next Wednesday, because
okay,
if we didn't have a federal holiday, we'd have B group on Monday. But yeah, there's nothing going on. The campuses are closed on Monday.
Yeah,
Memorial Day and all that.
Mm-hmm.
So
and they're in class, so we go to the campus and everything, right?
Yes. So next week, the B group has, which is June the 2nd, okay, you will have class on the Norfolk campus in the Andrews building on the 4th floor. You get off the elevator, walk up the long hallway where all the glass windows are in the direction of the bathrooms. And we're almost the last door. We're the second to the last door up the hallway. That is the Chem 111 lab.
Okay, thank you.
All right, let me open up my document. It's just somewhere. What did I do with it? That's why I have more than one document open. Why can I not see it? Show all windows. Okay. That zapped me. Oh, there it is. I had something else I was working on earlier today, and I had not closed that document, and for some reason it like overlays it. All right, so we got as far as physical properties and talking a little bit about the intensive and extensive stuff toward the end of class on, I don't lose track of days again, Tuesday. So moving on a little bit. Now we want to talk about the changes, first from the physical end. And one of the things that the textbook has to say is kind of vague. And it talks about the not changing the identity, okay, which sounds really strange because it's like, well, okay, if you have a sheet of paper and you tear it in half, well, now it's 2 sheets of paper. That's sort of, it makes it sound a little bit more complicated than it is. The idea is supposed to be that the molecules themselves have not changed their identity. You can boil something, freeze something, melt something, cut, saw, grind. All of those things fall in the category of physical changes. And I think I have the page number correct. If you want to go back later and have a look at page 27, it talks a little bit about distillation, which is essentially a process that boils a substance, turns it into a vapor, and then passes it through a condenser, and then recondenses it back into the liquid form. Obviously, this is how they make booze, okay? If you want to make whiskey and you are distilling it, you have to boil the ethanol up into the vapor phase, pass it through the condenser system, and then it comes back into liquid phase and dribbles out the other end. This is also how they distill water. Okay, if you buy a gallon of distilled water from the grocery store, this is what they did in order to get rid of impurities. Filtration also involves physical changes, and there's some other things you can look there that are all sort of related to lab topics. All right, so then we switch from physical to chemical. Now, chemical properties and chemical changes are very close to the same thing. The biggest difference being that a property may or may not have happened yet. So if you say, I have gasoline and it is flammable, but you haven't put it in your car engine or you haven't set it on fire yet, it is merely a property. It has the ability to undergo that particular event, but it hasn't happened yet. The chemical changes imply that it is either in the process of doing so or it has just completed that change. So the properties for the chemical properties and changes for the chemical version are a little bit more subtle. We're not going to spend a lot of time about that, except in terms of how they apply to lab. As we progress through the semester and do various labs, we will talk about some of the physical changes and some of the chemical changes that are occurring as you are doing labs. If you have a chemical change happening and you write it down, the things you put on the left-hand side get dubbed the reactants. The things that get written on the right-hand side are dubbed the products. And obviously there's an arrow in the middle. That's the way chemistry equations are written, as opposed to an equal sign, we have an arrow. You can use a bunch of different words to represent what the arrow designates. You can say yields, you can say gives, makes, reacts to form. All of those things are ways you could state it. I'm not very picky about how it's written out that way. And I just gave you an example there that has 4 molecules of a molecule known as ammonia, NH3, that is reacting with 5 molecules of oxygen gas. And you get some trading around, and you get 4 NOs, known as nitrous oxide, and 6 water molecules. So that's a fairly typical looking chemical equation. As you're thinking about the idea of chemical changes, there are ways that you can see a change occur. And this, again, we're kind of getting back into more lab versions here. Things that will indicate to you that a chemical change occurred could be a color change. Okay. One of the ones that you will see frequently if you take second semester is adding an iron solution to a thiocyanate solution. Separately, they are both clear and pretty close to colorless. You dump them together and they turn this bright reddish orange color. You have a brand new 2021 penny, okay? You have it in your pocket, okay? Right at the moment, it's brand new. It's still that sort of pinky orange color because it's newly printed. On the other hand, if you pull a penny out of your pocket that was minted in 1994, it's kind of got a brown coating to the surface of it. Part of that is the chemical change. That is the copper reacting with the oils from fingers and the oxygen from the atmosphere. Other things that you will see. There is one lab in particular that is going to be rather specifically devoted to formation of solids, also known as precipitates. Sometimes precipitation is very slight and you only get cloudiness. Sometimes precipitation is very heavy and it almost looks like the snow globe is snowing inside your test tube. And if you leave it sit there for a while, all of the little fluffy chunks will begin to settle to the bottom of your container. Formation of a gas. Okay, back to really sort of middle school here. Vinegar and baking soda. Okay, how to make a volcano when you're in middle school. Part of the reason it foams up is because you're generating a gas. Specifically, that reaction generates carbon dioxide. But there are other gases that can be generated by many different chemical reactions. You can generate ammonia, you can generate oxygen gas, hydrogen gas. There's a handful of other ones also, some of which we will talk about in much more depth later. The last one is a little bit less visual. Heat or flame sometimes, or heat absorbed, okay? If you go to a ski resort, often in their gift shop, they will sell things that they refer to as like hot hands, which are basically little pouches that you crack, kind of like a siloom, and shake, and then suddenly they're hot. Also, MREs work that way, the little heating pouch inside the MREs. But also these days, if you buy a pre-packaged first aid kit, what you will often notice is it will come with a little pouch again that says, often the instructions say something on the order of place on surface and strike with fist. Basically you whack it and you shake it and it gets really, really cold. Okay. Both of those are chemical reaction based. The things that are inside the package are reacting and causing either an increase in heat or a decrease in heat. So I looked up a picture here that I kind of like the looks of. The hair bleach thing. Of course, I'm rocking the purple sort of right at the moment, although I need to go visit my stylist lady and get my purple refreshed because my hair is not as purple as it was before. Changing in temperature, okay? Once you set something on fire and the fact that it keeps on burning, okay, that helps to indicate to you that the reaction is happening. Combustion. Production of a gas. It's showing you something that kind of looks like an Alka-Seltzer. And production of a solid. Okay. If you make cottage cheese from whole milk, that's a process, okay, which causes the curd to form. So all of those are things that we will see at one point or another in lab. All of those different indications of reactions are dealt with by at least one lab this semester. This is a chapter that has a lot of sort of different subjects all kind of lumped together here. So we're about to switch topics again. Measurements. Obviously, part of this is done in lab, but also we talk about it from a more mathematical point of view. They are quantitative observations. So you've got two parts to this. You've got the number part and you've got the unit part. Okay. So send my husband, who just walked upstairs, to the store and say, but go buy flour. Okay. If I don't tell him how much, if I only tell him 5, okay, he's a programmer, he's really literal, and it actually in my household would not be completely unreasonable to buy 5 bags of flour at one time, especially if it was like November and I was doing lots of baking. So a number without a unit doesn't tell you enough information. So back to the flour idea. If you do shopping in the grocery store, in a regular grocery store, usually flour comes packaged in this country in 2 pounds, 5 pounds, and some of the supermarkets carry 10 pounds. Of course, I also shop at Costco, where you can buy 25 and 50 pounds. And yes, I have bought 25 or 50 pounds of flour at one time occasionally. So if you give somebody a unit, say pounds, okay, but you don't tell them how many pounds, you're back to the same kind of problem. You need 2 parts for the measurement to actually make sense. Because of the things that we are dealing with in chemistry and science in general, often occur as extremely large numbers or extremely small numbers. And I just realized I misspelled appropriate. We will often use scientific notation as a more shorthandy version of how to express these numbers. Exponential notation and scientific notation are actually not exactly the same thing. Exponential notation only has a power of 10, but the front half may or may not be between 1 and 10. We're trying to stick to the scientific notation end of things. So your front number should be between 1 and 10. And I gave you a couple of examples here. to remind you that large numbers are going to have positive exponents. I gave you the number 4 million. When I convert that over into scientific notation, I am moving my decimal point from behind that final right-hand 0 all the way over to between the 4 and the first 0. If you have a tiny number, you are going to have negative exponents. This time you are moving your decimal place in the opposite direction. So I have 0 point, and there's 4 zeros there, and then 3, 4, 8, 9. I move it from all the way relatively far to the left there. I move my decimal place to between my 3 and my 4. Note my exponent has a negative value. This is something that you need to be proficient in doing both for lecture and lab. So now we're going to segue over to the units end of things. Système International. The French invented it, they get to name it. It is kind of sort of the metric system, but also not exactly. There are a few subtle differences. So looking at the units here, meter is your base unit for length, but here's where the next one down is where you have a little bit of difference between straight up metric and SI. Straight up metric has mass in grams. SI is considered to be kilograms. If you have taken physics, you will notice that I think the physics actually uses the SI units a little bit more even than chemistry does, especially when they're converting to things like newtons. Times in seconds, here's another subtle difference. Temperature is not Celsius if it's SI, it's Kelvin. Celsius is just straight up metric. Moles, amps, candela, if we're talking about how bright your light bulbs are. Everything's base 10. I am eternally frustrated as a scientist that the US is one of 3 countries in the entire world that doesn't use metric. I travel fairly extensively, and yeah, you're in Europe, Europe or wherever, and it's like everybody else uses metric. Yeah, the US and like 2 other teeny tiny countries. Because it's all base 10, there are prefixes that designate what those powers of 10 are. 5 of them we will use extensively. There are others that you will see occasionally, but will not get used as often. Kilo is the one that's bigger than 100. It's bigger than 1 unit. Okay, so kilo is 1,000 or 10 to the 3rd. We have deci, centi, milli, and micro. So 1/10, 100th, 1,000th, and 1,000,000th. There's some more listed in your textbook, and there are some listed in your lab book. Actually, let me flip the lab book open and give you a page number to look at some point. If you look at page 45 in your lab book, there is a table at the top of the page, which not only includes these handful, also includes the less used one, things like femto and pico and nano and mega. And actually, I forgot to change my notes because the mass thing, the way the mass is designated actually changed recently. I need to go back and fix this. So length actually is based upon the speed of light. They did a calculation because obviously light in a vacuum has an immutable speed. If you use that tiny, tiny fraction of a second there, 1/299,792,458, okay, so tiny, tiny fraction, you will get a meter. That's how far light travels in that particular time period. And as I said, I realized I didn't go back and change this. So up until last year, okay, the purest version of a kilogram was, of course, the object still actually exists. In a deep, dark vault in Sèvres, France, there is a platinum and iridium cylinder that is considered to be the perfect kilogram. Recently, they changed this designation to a calculation based upon the gravitational constant on the surface of Earth as a way to calculate 1 kilogram. So that actually, I need to find a reference and insert that at some point. Not that it's of like super amazing importance, but it does tell you where they got this information. All right, time is based upon radioactive clocks, specifically cesium clocks. Cesium decays very fast. And if you have about 9 billion-ish periods of radiation from a cesium clock, that is basically 1 second. There are a handful of cesium clocks around the world. The closest one, I think, to this area is the one that is located at the Naval Academy in Annapolis. There's also one in London, well, actually on the suburbs of London, the Greenwich timeline. And there's a handful of other ones. I think there's one in Denver. There's one in Tokyo. So all of them are based upon this radioactive decay constant. So this is how they determine what time frame is. So one of the ones we've kind of skipped around is, or not mentioned, is volume. So volume is actually not a direct unit. Volume is, okay, it is literally how much space something takes up, but it's based upon the length measurements. If you had a little cube that is 1 decimeter or 1 centimeter on each side, that will give you a liter. So you have 10 centimeters by 10 centimeters by 10 centimeters. And hang on just a second. 10 by 10. Oops. All right, to give you visual aids. This is a liter, okay? This is also my husband's Rubik Cube. We have a whole bunch of these in my household. We've got the 3, the 4, the 5, all the way up through the 10, okay? So think about it though. It's like each one of these, this is basically a centimeter. So this is a liter based upon the way a liter is defined, which is an interesting concept because it's a extrapolated idea as opposed to a more literal idea like the length or the mass or even the second. One of the things that my people who did lab yesterday experienced was the idea that liters, actually specifically milliliters, and cubic centimeters are the same thing. 1 milliliter equals 1 cubic centimeter. You can then also say that 1 liter is 1,000 milliliters or 1,000 cubic centimeters. Now you should be able to convert back and forth because this, again, being metrics, is a decimal move. If you have 1.23 liters and you convert that into milliliters, you're moving your decimal 3 spaces to the right, and that will give you 1,230 milliliters. All right. Let us take about a 10-minute break, and we'll pick up with some accuracy and precision stuff at 5 o'clock, so in about 10 minutes. I don't know if anybody tried to get their lab book from the Virginia Beach campus bookstore. I just found out from my kids who went to buy try to buy my daughter's book for her STV class. The bookstore closes at 3 p.m. It's like, that's kind of head scratchingly ridiculous.
Yeah, I got mine today, but before 3 because I saw it was 3. I was like, that's too
Yeah, it's like
early.
you'd think that at least at the very least, the first week of class, that they would stay open till 5 o'clock. Yeah, that just, and then tomorrow they're only open till 1. I have an appointment in the middle of the morning tomorrow, so I'm hoping that maybe I can go dash and do that and then take my daughter down to get her book. Yeah, she's taking STV, which I've heard people describe as how to student. She's a graphic arts major, so one of those things she has to knock out. All right, so hopefully everybody is back. Teaching from home is always really just kind of weird. Even when I lecture though on campus in the summer, we always take a break in the middle of the 2-hour time block because it's sort of information overload. Also, I start losing my voice. So we're trying to get you the right amount of information and not hopefully completely make you brain numb. All right, more topic switches. Accuracy and precision. And actually, okay, I'm going to end up switching over to the whiteboard to draw the paperclip thing because otherwise it doesn't make any sense. Accuracy and precision. Commercials often do not use the terms correctly. Accuracy is how right you are. So for instance, those of you who did lab yesterday or who have done lab, the first lab of the semester, one of the things that you are measuring are the densities of some metal solids and some liquids. And I judge, among other things, your accuracy. And I have this sort of plus or minus amount that I consider to be normal for average, student use and their ability to get within certain values. Precision, though, is reproducibility. And one of the things that especially people who've already done the lab will notice is that a lot of things are done more than one time. There is the measurement for the mass of 7 milliliters of water, and I have my students do it 3 times. There's actually 6 blanks in the lab book, but we usually do only 3 of them. But it's still reproducibility. When you are doing the density portion of the lab, you do the density of the solid twice, you do the density of the water twice, and of the other liquid twice. Hallmark of good science, okay? Can you get the same result or really close to the same result more than once? Okay, this is what you're shooting for to prove that your data is valid. Ideally, you are hoping for both. Ideally, not only are you pretty close to right, you also are able to do it more than one time. Okay, so this is kind of what you're shooting for. So let me switch over to my whiteboard and you get subjected to my really horrific drawing using this system. All right, so Oh God, that was awful. Let me try this again. Okay, that's a little less awful. This is a giant paper clip, okay? And let's say that these are centimeters. But this is a cheap ruler, and there's no marks in between. So we have, let me stretch out my bar here a little bit. So we have a 0, we have a 1, 2, 3, 5. Okay, so 5 centimeters, units, whatever the units are. So based upon looking at this, if I poll a bunch of different people, they would all agree that the paperclip is longer than 4 units, but less than 5 units. But then you have to ballpark it as to where in between the 4 and the 5. And so some people might say it's a little less than halfway. So maybe it's only 4.4. A couple people might say, oh no, it's lopsided, so therefore it has to be 4.3. Some other people might say, no, it's really pretty much halfway in between, 4.5. Where your variability is coming into play there is that everybody is agreeing on the 4, but the digit after the decimal place is the uncertain one. So depending upon what kind of instrumentation you are using, your uncertainty is usually the amount based upon your last decimal place, okay? And then if you have all the ones you agree upon, all the digits you agree upon, plus the first uncertain one, these get referred to as sig figs. We're going to spend some time this chapter dealing with sig figs. We also deal with them to some degree in the first lab. Then we're going to kind of not pay a super lot of attention to them in some later chapters of the semester. Part of this is based upon the fact that although we all do sig figs in the science world, the amount of importance that we place on them in any individual given time frame tends to vary. So in between my academic stints, I did actually work for an analytical lab for a while. We did heavy metals analysis, specifically a lot of lead analysis. And twice a year, the accrediting body that gave us our licensure would send us a sample set to analyze. And we would spend about 3 or 4 days doing the analysis and making sure we were reporting all of our values to exactly and precisely the correct number of sig figs given our instrumentation. And we would tweak our spreadsheets on Excel to reflect that. And then we'd sort of forget about it for the next 6 months because we had adjusted all our spreadsheets to match. That's actually kind of the way reality works, okay? Sig figs are something you pay attention to at particular times, usually during instrument calibration, and then you pay less attention to them kind of at other times. If you grab a battery, okay, like a D cell, and you have a cheap balance that doesn't give you any decimal places, okay? One of the ones that like you use in elementary school, you might say the battery weighs 61 grams. Well, what if you have a slightly better balance that gives you a couple of decimal places? 61.23 grams. So in the second case, your 3 is your uncertain digit. In the first case, your 1 is your uncertain digit. It's the one furthest to the right. Since some of you have done lab, you will know that the balances we use in our lab are reporting to 3 decimal places. That makes the third decimal place the milligram spot, the uncertain digit. And it's doubly uncertain because since we don't have marble bench tops, if somebody else walks behind you while you are trying to weigh something in lab, you will often notice the last decimal place on the balance fluctuate rather wildly. So yeah, there's sort of an extra uncertainty in that. There are rules on how we make decisions from a mathematical point of view. One of those rules is if it's not a 0, count it. It's a sig. Leading zeros, meaning that your number is very small and less than 1. The leading zeros are not counted because you could write that number in some scientific notation. So I have 0.00014. I could write it as 1.4 times 10 to the negative 4th. Only the 1 and the 4 are significant figures. The others are basically placeholders. Captive zeros, in between other digits. They are always significant. I picked the random number of 1073. The 0 is in between the 1 and the 7, so it is significant. There are 0 presence of a decimal point. Did my internet just drop out? That was weird. I got this weird thing on
Yes.
my...
It did. It froze for a moment. It froze for me. I don't know if that was me or you.
Yeah, no, I got this little thing across the bottom of my screen here that says internet unstable. That was weird.
It froze. I thought I was looking at it like, what happened to the computer?
Yeah, it freezes for me too.
Okay.
All right, hopefully that won't happen again. So presence of a decimal point is a important factor for the trailing zeros. So if you look at the first number there, I've got 4,500. Doesn't have any shown decimal points. I am going to assume that this is a ballpark figure and only the 4 and the 5 are significant. Look at your second number there, 210.0. It has a decimal point, and whatever I'm measuring, whether it be centimeters or grams or something like that, because there is a decimal point in the number and there is another digit after that, I am going to assume that there are 4 sig figs. Now, textbooks, if you look through some of the questions at the end of the chapter, will sometimes try to kind of trick you. And they will give you a number with a bunch of zeros, and they'll put this point in there, and it leaves you kind of scratching your head as to, well, was that a period? Or was that actually a decimal point? They're trying to make a point out of it of, if you have zeros, but you know your value to the nearest 1, then you are allowed to count your zeros. You won't see a lot of this, but it does happen. Now, exact numbers, there's a couple of ways you can deal with this. Physically counted objects. Okay. If you go down to the beach campus on a normal semester, and the parking lot is full, and you say that there are 1,020 cars or vehicles on the campus, okay, you can't really have half a car. Well, not easily anyway. Because they are physical objects, they don't have an error value to it. So I have 3 cats. Okay, so 3, you could say 0.0, but I can't have half a cat. So you have a finite number of objects. You will also see definitions kind of thrown into a category. Pi obviously has no designated number of decimal places, but we often just use the rounded version if you're doing math, 3.14. E, 2.78, and yeah, that one also, like pi, kind of keeps on going. Also, definitions telling you that there are 100 centimeters in 1 meter would not influence a math problem because it is considered to be a definitional end of things. All right, applying said rules to the math. Part of this does involve some rounding. We're going to use the same rules that most math classes use of if the number that is where you are, actually, I said preceding, maybe I should have said succeeding. The number on the right-hand side, okay, is 0 to 4, you're going to round down. If the number is 5 to 9, you round up. So standard rules of math. If I have 34,879, and I want to round that to the nearest 1,000, actually to the nearest 100. So I'm rounding it to where the 8 is, okay? But I have to look at the number that comes afterward, okay? The number that comes to the right of it. And I have 8, 7. So I'm going to round up and call it 34,900. For the math end of things in terms of calculations, there are 2 rules. Now, the first one applies to multiplying and dividing. And again, I have weird misspellings here. 18.6 divided by 2.1987. So the number on the top of my division has 3 sig figs. The number on the bottom of my division has 5 sig figs. My answer should only have a match to the smallest number of sig figs. So my answer should only have 3. This is a 2-part type of problem. When you're doing these types of problems, first, put the number in your calculator and figure out what the calculator thinks the answer is. But then you are probably going to have to round. So if I put that math problem into my calculator, I get 4.59, okay, whole bunch more digits. But I'm only allowed to report 3 of them. So the 8, the 4, and then I have to decide, okay, do I leave the 5 alone or do I round up or down? So because there's a 9 after my 5, I am going to round this up and call it 8.46. Now the rule for adding and subtracting is different. It is least number of decimal places. So I'm adding two values here, one of which has two numbers after the decimal and one of which has three. So again, I'm doing this as a two-step process. Do it with your calculator first, then figure out how many figures you're actually allowed to report. So if I add those two numbers, I get 10.213. But because my 5.95 only had two decimal places, my answer is only allowed to have two decimal places. This one I'm rounding down because the 3 is that 0 to 4 rule. And 10.21 should be my answer with appropriate sig figs. When you get ready to do the homework problems, I did not mix and match. Okay, I gave you a couple of problems that use the multiply divide rule, and I gave you a couple of problems that use the add and subtract rule. I didn't mix and match them to try to make things a little bit more straightforward. All right, since we're heading down the math pathway, the next section of there is for us related. You can call this a couple of different things. Some textbooks like to call it factor label. Some textbooks just call it dimensional analysis. Some of them just flat out call it conversions. It all kind of amounts to the same thing. You are going from one unit to another unit. So I gave you a couple of typical conversion factors to kind of eyeball here. 1 meter is 1.094 yards, or 1 kilogram is 2.205 pounds. There is an excellent appendix in the back of your lab book that has a whole bunch of useful conversion factors all on one page. So keep that in mind, especially when you are doing Dry Lab 1. So one of the things that you're doing with this is you're using these things that we're going to call equivalence statements. Something equals something else. But then it also leaves you with the need to decide, well, am I multiplying or am I dividing? In the rules of math, the thing that you are trying to find must go on top. The thing that you are trying to cancel out must go on the bottom. So I started with my stick of butter weighs 1/4 pound. How many grams is that? My conversion unit is 453.6 grams per 1 pound. I could write it either way, but it depends upon what I'm using it for. I could either have the pound on the top or I could have the pound on the bottom. In this case, I want the pound on the bottom because I want it to cancel out with my 1/4 pound. So when I set this up, I've got 1/4 pound, and then I have the grams on the top and the pounds on the bottom. That way, my pounds go away when I do the math, and I have 113.4 grams. How about money? Conversion factors. There's a very, very small chance that I might actually be going to Iceland in between the summer and semester, fall semester. So I've actually been sort of looking at Icelandic kroner. Usually my family and I typically tend to travel to Britain because we have family over there. I don't think actually the conversion factor is quite this bad right at the moment, but it was when I originally constructed these notes. 1 British pound, also known as a pound sterling, is a $1.63. So if I have if I have a $20 bill, what does that represent in pounds of money. So I use my conversion factor, and since I'm going from dollars to British pounds, I'm dividing by my $1.63. Gives me 12 pounds and 27 pence. Now, some of the things that you are liable to do are more than one step. And I just realized I did something weird here, that I deleted one of my conversions. All right, let me go back and see if I can fix this. Oh, no, that's wrong. Yeah, I'm gonna need the appendix because I don't remember the backwards version of that. So 0.239 calories. Yeah, I don't know how that ended up getting deleted from that line. All right, so this is how it's supposed to be set up. Okay, cinnamon buns, the kind that come out of the can. 230 kilocalories, okay, because a kilocalorie is 1 food calorie. However, if you buy food that is produced not in the US, they don't use calories in all the other countries of the world. They use joules or kilojoules. So I want to convert to kilojoules. And actually, I just realized I actually had my conversion factor there. I still don't know why I ended up accidentally deleting that. I have 230 kilocalories, and I first want to go from kilocalories to calories. Okay, so that's my step 1. So 1,000 per kilocalorie. Then my middle step, 1 joule per 0.239 calories. But that only gets me as far as joules. I want kilojoules. So I have one more step. 1 kilojoule per 1,000 joules. As you proceed across the math here, you can cancel out each pair of units, cancel out your kilocalories, then cancel out your joules, then you should have kilojoules left. You can also cancel out the 1,000 because there's 1,000 on the top and 1,000 on the bottom. Ultimately, you end up with 962.3 kilojoules. So you can do them one step at a time, or you can boxcar them together, which actually is a term I had not heard of until recently. Some high schools call it the boxcar method of multiple or serial conversions, where you go through several different separate conversions to get from one unit to another unit. I had thrown a problem in here that it doesn't look like like I said, I glitched something in my notes here. There was supposed to actually be a example here. Which I don't have all the units for. Let me do it on the whiteboard. All right, so we had, okay, a butt is like, it's like a big barrel. So the butt was 126 gallons. All right, so, all I have 126 gallons. I'm going to multiply that by the fact that there are 4 quarts per 1 gallon. Okay, so I flung my calculator here somewhere. All right, so we have 126 times 4. That will give me 504 quarts. Okay, but now I need another conversion factor because it says find out what the answer is in liters. So back to my appendix here of what is the equivalence between a quart and a liter. And so we have 1 liter is 1.057 quarts. Okay, so this has 2 different conversion units that are sort of linked together here. And I'm now going to take my 504 and divide by 1.057, and that will give me 476.8 liters. Okay, so I did it as 2 separate conversions there. You could link them together, okay, and cancel everything out appropriately, or you could do them as 2 separate steps. It won't actually change your math. All right, let's go back to my other file. All right, so before I jump topics again, let me also point out that there's a couple of examples that are in your textbook that you can also go back to have some additional examples. Are there questions about, thus far, the dimensional analysis end of things? This is often the topic that leaves people most likely to be a little bit head scratching. I will confess, I like word problems. I like interesting word problems. You will see a couple of those interesting word problems on the homework set. All right, we're gonna jump topics again. Temperature. Okay, if you ask average person on the street, what's temperature? Okay, we've all been obsessed with temperature, among other things, as well as toilet paper, over the past year. It's like every doctor's office you go into, the first thing they do when you walk through the door is take your temperature. If you go into a whole bunch of other places, they take your temperature. I belong to the Jewish Community Center because they have an amazing pool. And it used to be you walked in the door and there was somebody on duty there to take your temperature before you were allowed in the building. Now they have this automated thermometer that's like nailed to the wall. You like bend over and like so that it can see your forehead. I don't know how long that will stay there, but it's been sort of a fascinating set of events. If we step back and look at the idea of temperature from a bit more abstract point of view, okay, what if we didn't have scales? What if we didn't know what the scale of temperatures was? We could base it on how much kinetic energy the particles of a sample have. Hot things move fast. Okay, that's the rule of the physics in the universe. Okay, cold things move slow. Therefore, our creation of scales is actually something that's a human design. we have the one that we here in the US are kind of stuck on, which is Fahrenheit. We've got Celsius and we have Kelvin. All of them are sort of tied, however, to the concept of water boiling and freezing. And I found this little illo that I like the looks of. If you're on the Celsius scale, which is the far left-hand one there, you can kind of see 0 and 100 as freezing and boiling for water. You have Fahrenheit, so 32 and 212. And then there's Kelvin, which has no negative values. Kelvin is based as an absolute set of data. And you can kind of look at, and one of the reasons I really like this picture was it kind of gives you an idea on how this all lines up. Because on the Kelvin scale, water freezes at 273. And if you drag all the decimal places with it, you could say 0.15. But that's in comparison to absolute 0, actually quite a ways up the scale. Okay, absolute 0 being this unreachable spot where nothing moves. The electrons don't even orbit the nucleus of your atom. They just kind of sit there. So to give you just a little hint of backstory here, Celsius was a famous white dead guy, okay, Swedish. He's the one who came up with the idea of the Celsius scale. He was actually a watchmaker, and he had screws, because of course this was way back when, that were designed to wind the watches. And he took a glass tube and he inscribed it with 100 equal marks to match the boiling and freezing of water. So this is kind of why it actually makes a little bit more sense. It's a nicer scale to deal with. It also means that 1 degree Celsius is a slightly larger space of temperature than a Fahrenheit degree. Now, Kelvin's another famous dead guy who we will see again later. Kelvin was his title, not his name. His name was William Thomson. And he is the one who the Kelvin scale is named after. Celsius and Kelvin are very, very closely tied together, in that Kelvin is Celsius plus 273. And like I said, if you want to carry all the decimal places with it, technically it's 0.15. Celsius can be Kelvin minus 273. So getting back and forth between those two is really pretty straightforward. You're either adding or subtracting this fixed value. Going back and forth between Celsius and Fahrenheit is messier. I use the fraction-based equation. If you experienced it in a high school class, in another class that uses the 1.8 value, it's not going to give you different answers, okay? It's just a different version of the same equation. If I have 38 Celsius, it's actually hotter than 38 Celsius outside today, maybe. No, maybe not quite. Feels like it's hotter than 38 Celsius outside. And I want to figure out what that is in Fahrenheit. I'm going to multiply by 9/5, and that has to be the first step before I add 32. And that will give me 100.4. One of the things that I have done in a lot of these problems is to kind of match up with the instrumentation that we have available in the labs. We have two different types of thermometers that we use in the lab. One is the $3 glass version, which is filled with alcohol, has the red stripe in it, which are easy to clean up if you break, and also are safe to use in acids and bases. You can only maybe read them to the nearest half a degree. We also have digital thermometers that we use for some other labs, but even those only read to the nearest 10th of a degree. So I did not do any of my calculations past 1 decimal place for these examples. Makes them match up with lab data a little bit better. How about going in the other direction? If I have Fahrenheit and I want to do Celsius, okay, 350, standard baking temperature for lots and lots of things. If I want to figure out what that is in Celsius. First, I'm going to do the subtraction, okay? So order of operations, pay attention to your parentheses here. 350 minus 32. Then multiply by the reversed fraction, 5/9. So subtract gives me 318, multiply by 5/9, I get 176.7. Now, what if you had to go more than one step? Sometimes you might have to convert all the way from Fahrenheit to Kelvin or back. Do it in 2 steps. Okay, the two have to be done as kind of like 2 separate parts to the equation. First, I took my 106 Fahrenheit, subtracted my 32, and multiplied by 5/9. That gave me 41.1. Then I added my 273 to it, and I get 314.1. So keep in mind that some of these temperature conversions are kind of more than one main step. All right. Again, topic hopping. Density. Some of you got to do this in lab yesterday. Some of you will get to this in lab next week. Density is a comparison. Density is mass per volume. In different fields of science, there are many different ways you can deal with density. You can deal with pounds per square inch. You can deal with kilograms per square meter. We tend to, in the chemistry world, predominantly deal with either grams per milliliter or grams per cubic centimeter, harking back to that idea that a milliliter and a cubic centimeter are actually the same amount of space. You will often see textbooks stick to cubic centimeters if they're talking about solids, and then resort to grams per milliliter if they're talking about liquids, but actually it doesn't make a difference. The other thing you will notice as you look through examples and do lab, densities above 30 in the grams per milliliter unit are really, really, really unlikely. Okay, so if you had lab yesterday and you hadn't crunched your numbers yet, and you told me that your little metal cylinder that you determined the density of in lab had a density of 422 grams per milliliter, when I grade it, I'm probably gonna like put a circle around it and write something snarky like oof on it, or impossible, because that's kind of true, okay? In the world of average, normal, everyday things, you're not likely to see anything with a density higher than 30. Water is 1, more or less. That's slightly temperature dependent. At 4 degrees Celsius, water is exactly 1 gram per milliliter. You do need to be able to manipulate this equation. Solve for D, solve for M, solve for V. So I gave you 3 examples. There's also some more examples in the textbook. What if you had a liquid? Okay, we did pipetting of liquids for those people who had lab yesterday. 43 grams in a volume of 39.5. That one's kind of the most straightforward version of the equation. Take your grams divided by your mils. 43 divided by 39.5 will give you 1.09. What if you had a gas? Okay, there are ways to measure gas densities, and technically speaking, you should actually know some additional information like temperature and pressure, but I just kind of simplified this problem. What if my gas was 0.0021 grams per mil? And the whole thing only weighed 1.6 grams. What's its volume? Plug in your pieces. Do your little algebraic flip, okay, such that you want your V by itself. You're going to have 1.6 divided by 0.0021. Your volume is 761.9, or if you round it, 762 mils. Technically, if I was following sig figs, I have 2 sig figs in 1.6. So from that point of view, it would be 760 milliliters if the question asks for your answer in sig figs. And the last one, I gave you a density, 10.5, and a volume of 18.2. Again, put all your data into your equation, do your little algebraic rearrange. Your milliliters will cancel out. And actually, I left out I put the M and didn't put the L in. I just realized that. That's supposed to be in there. Actually, no, that's not the M. That's the M for mass. That's why I'm confusing myself. So mass, after you multiply these 2 numbers together, should give you 191.1. And that is the end of chapter 1. Okay. So we have completed all the data, all the information you need in order to do the first homework set. You get your 3-day weekend. You get extra time to work on this. Because I won't make it due at like some weird time. I won't make it due something that's not a class day. So this will make your homework set due next Tuesday. Let me click over on my thing here so I can actually figure out what date that is. That's actually June the 1st. So I will go back and now set the homework due date for chapter 1's homework as midnight on June the 1st. That'll then give me Wednesday, the day after that, to grade it. And then Thursday, I will publish the answer key for the homework set, and I will go over it also. I mean, yes, we will continue onward with chapter 2 on Tuesday, but it gives you a little bit of absorption time to kind of process the information and make sure you have some understanding before the test pops up. So, okay, think about this it took us 2 class periods to cover chapter 1, and then probably 2 class periods likely to cover chapter 2, and then an additional day to go over homework. So the first test ends up being approximately 3 weeks from the beginning of the semester. And then after that, because we only have 10 weeks in the semester for the summer, after that first test, Then tests start occurring approximately roughly every 2 weeks, every 2 to 2.5 weeks for the remainder of the semester, because we have 4 tests spread over 9 chapters. Well, truthfully, 8.5. Questions? Homework is already loaded to Canvas. Okay, I already loaded that before I actually activated the shell. So the homework set's already there. When you click on modules, it should be inside the module. Okay. And then, like I said, you can do it a couple of different ways. It's loaded as a Word document. You can literally open the Word document, type your answers in, hopefully with some work too, for certain problems, and then just save it with like your name at the end of it and sub it back to me through Canvas. Or if you prefer, if you like writing handwritten stuff for working on homework problems, you can print it out, write it, and then either scan it or take a picture, because the Canvas is also set up to accept PDFs. If you are a Mac user, I will not guarantee that you will not have weird problems. Canvas is less friendly to the Mac environment than it is to the PC environment. So, questions? Lecture, lab?
I do have a quick question. I don't know if you went over the textbook situation. Do we have to have the textbook? Or are the tests going to be
Are we talking about for lecture or for lab?
lecture?
So one, it's free. Okay. When you open up the syllabus and you scroll down to the second page, it's a PDF file. It's like an 18 meg PDF file. Actually, it might be a gig. Anyway, it's just a PDF file. It's free. Okay. All you have to do is download it. Some people like to buy textbooks. In fact, I know one of my people I had for lab yesterday, however, rented the textbook. She said it cost her $26 for the whole semester. But if you like digital textbooks, it is literally free. We specifically switched over to a open source textbook for our chemistry department, so that was not a thing that people had to worry about paying for. You do need a lab book, though. You do need a physical lab book. I think that the MacArthur Mall, Barnes and Noble might be the only easy place to get that. But as far as textbooks go, you are free to use the literally the free PDF version.
Okay, thank you. And would be most of the text material or test material be from our notes and what we go over during Zoom?
If I didn't talk about it, I'm not going to test you on it.
Okay, thank you.
The biggest usefulness of the textbook, which I like, okay, it's not the best textbook I have ever taught from, but it's certainly not the worst. The biggest advantage of the textbook is it gives you extra examples. Okay, because I only give you a certain number of examples to study from. Having the textbook file means you can then look at their examples also, and it gives you help for like, okay, well, if I'm doing this homework problem and I'm looking for an example to base doing the homework problem on, that way you have several different examples.
Okay, thank you. Have a good day.
Any other questions? Otherwise, I will see everybody on Tuesday.
Thank you, Professor. Have a good night.
Bye. Yeah, I see somebody said they're having like Zoom problems. Yeah, it happens.